All right, let's put the HP 4155 into service. Okay, this has been left on from before, but I'll just turn it off. Okay, and now you can turn it on, and it takes a while to boot. I'm just going to let it be. All right, and I have some parts here for testing. These are diodes. Hard to see here, but there's a kind of a dark stripe on one end, that's the N side, a non-stripe, that's the P side. We have yellow diodes, we have red, and we even have green, right? And in all cases, the long side is the P side, and the short side is the N side. And we also have resistors, which shouldn't matter which way the current is flowing. All right, and these will be here for you. All right, this is the back of the 4155. You need this controller. Otherwise, you can't communicate with the machine. It all plugs into back there. It's like a rat nest. This is a light source, but we don't need that for today. This is the back of the control box, and so everything, you never should have to deal with that. No one would touch that. All right, and then here, it's the 1644 2A test fixture, and what we can do is we're going to have a source measurement unit 1 and 2, and we're going to just plug them in to positions 1 and 2, and that means over here we can just, for instance, plug in this diode 1 and 2, and we're always going to try to put the positive side in 1 and the negative side in 2. So right now that one's the power or signal conditioning diode. If I were to use the red diode, I'd put the long side in. Same with the green, long side into 1, and same with the yellow. And the resistor, again, shouldn't matter. All right, then the final thing is we have to wake up the machine. All right, and you have to press Control-Alt-Delete to log in, which just let me pause and log in. All right, we're recording again. Sometimes if you haven't logged in a while, the internet is off. I do, even though we have a dongle for the license, I still think the internet needs to be on. Or if you change accounts, you might have to click on EduRoam yourself. Okay, but we only have wireless connection here. Now we come over. It's MT ICS. I'm always calling it ICS metrics because that's what it used to be. So we just double click. And it should open up. Here we go. All right. Now this software is $5,000. It has a dongle, but it's node locked as well. All right, so sometimes these might, I'm just going to see if I can open up a project. So this PC local, there's some projects that should already be here, right? And I was working on something called IV129 2-terminal ICS. Your account should be able to see this as well, but you know, if not, right, I'm going to show you how to do your own thing. So first thing we need, the GPIB, we just confirm that, it's fine. So we want to select our instrument, and we have a whole sorts of things it can do. We choose 4155-6. Now, our actual machine is a 4156A. That's okay. Let me zoom in a little bit. And we'll press connect. And we do okay. Great. Now, we're going to set up a test. All right. And I'm going to do a new one. And I'm going to call it, resistor. Okay, and I can choose what it looks like. So I'll choose a resistor. Great. Now I need to add some inputs and outputs. That's sources. So 4155-6 SMU1, right? I just click on that and then click on A, right? That corresponds to this one, connected to one, connected to here. All right, and I'm going to pause it a little bit and switch out for a resistor later. All right, so we need another connection, SMU2, and we'll do done. Now SMU2 is going to be our ground, and we just call it a voltage stimulus, and we're just going to set it to 0. It has various voltages. We don't need to measure any of that. The compliance is 100 milliamps, which means if it goes over 100 milliamps, it won't let it. Okay. Now we're going to do the actual experiment. So we're going to measure the voltage of the resistor. Okay. And so I'm just going to call it VR for voltage across the resistor, and IR. All right, we're not going to keep it constant. We're going to sweep it, and I'm going to go from -1. I'm tabbing through there. I'm going to keep the same number of points, the compliance, all of that. Okay, and I'll click done. All right. Now I want to do something first, and I want to click on workspace, and I want to sync it. Like, it might come like this, none, if you're doing it. All right, and you can sync data to Microsoft Excel. All right, everything else you can say is fine. Okay. Now, measure, we're going to bring up the measurement icon, or measurement pop-up. All right. So, this will take one measurement. This will keep repeating it. This will append it to the old measurement. You can have the history, auto. And then there's something called integration, which is how many averages it takes us. So, so if I click on user, short takes the smallest amount of averages, medium, and long. And it's a way to get rid of noise. All right. So I'm just going to click single. And if everything is going right, you should see it clicking through and automatically controlling the machine. And that is not a resistor, it's a diode, right? I said I was going to pause and switch it, but I forgot. That's okay. I'm going to pause. And we're back. So now you can see I've got a resistor in there. And just to see, I'm going to click on append. All right, and you can see it going. All right. And so now it's a straight line. All right, but we didn't really see it. So we got to click up here on this icon, plot. And VRIR, and I'll just say done. So you can see two things. This is the diode curve, and this is the resistive curve on the same axis. And it looks like the resistor isn't passing anything at all. we have some options. We can click options, legend setup, and I can do IR again, but in this case, do log. Okay? And of course, it won't show you anything negative, but now you can see that this linear relationship becomes logarithmic, and the exponential relationship becomes linear, which we're going to use later. But I just want to turn off this to none. Okay. And now we'll just do a single. All right. Okay. And now we're here. Now, I said it was a 10 kilo ohm resistor, but is it? Well, we can do something called a fit right with the software. Click on the cursors. I need 2 points. So that'll be Y1. And I'm going to click on that so I can kind of move it around. This refresh isn't quite the way I like it, but you'll see that it's okay later. Then I'll click this point here, and it already should be like that, and I'll move it up here. And what I'm going to do is just take another measurement, because then the 2 points should be visible. All right, now you can see the 2 points there. All right, it was kind of ugly before. All right, then I'm going to do fits. Fit 1, the square and the diamond, and I'm going to click this. And yeah, the resistor is so linear that that red line goes very, practically through those points. All right, and then we look at the slope, intercept, and so that slope is 1 over the resistance, right? So 0.0097 milli, 1 over that, is very close to 10K. So everybody should be able to do that. Now, sure, you can take a screen grab with the snipping tool. You can set this. I'm going to click this. I thought I'm going to do Windows tile, and here's the data, okay, which you can cut and paste, but it's supposed to go to an Excel file. So I'm gonna, hopefully it does it now. I'm just turning it off and on. Here we go. So by just turning it off and on, here comes this Excel file, which now you can save as CSV. You can bring it into LT Spice. You can do whatever you want with it. Plot it in Python even. Okay. So then the last thing, I'm not gonna save it, but I do want to save this project. So I'm going to save the project as, and I'm just going to call it 129 resist 129 resistor. So that might be in there for you when you come back. All right. Well, now I want to do a diode, so I'm just going to say new. All right, and I'm going to go through this again. All right, we have to choose the instrument. We'll connect it. All right, but now I'm going to have something called a diode. Now, just so you know, you can have a project that has resistors, diodes, MOSFETs, everything in it. I'm just trying to show you how the whole thing works. Okay. So we press OK. So now I want, where's the diode? Okay. So this is the P side, this is the N side. This will be 1. That'll be SMU2. So SMU1, SMU2. All right, I'm just double clicking. We just want this constant again. All right, now, I actually don't want, for what we're going to do, I don't want to sweep the whole voltage range. So I'm actually going to start at 0.1 because I don't want any negative values. It's going to cause me some troubles later. And I'm going to use 2.5 volts because the LEDs take a little bit more. And number of points, oh, 100 is good. Okay. So that's done. Let's just measure. Oh, no measurements have been selected. We're on diode. Sweep. Okay, this is a bit weird. Let me debug it and get back. Okay, I forgot to measure something, and that's why it was telling me nothing had been selected. Okay. Done. Measure. Another issue. All right, sorry about that. It seems there's something a little bit odd going on. So rather than make a different setup for each device, we're going to put all the devices into one setup. So if you might have to turn everything off and come back on and open up, or just start your resistor. Okay, now I'm going to add a diode. So I want a new device. I'll call it diode. All right, I will make it look like a diode. All right, I will put SMU1 there. Sometimes you click the wrong thing. You have to click done and then delete it and start over again. Sometimes it is a little bit difficult. This is already set up properly. I'm just going to come here and we're going to measure, but I'm going to call it VD ID. We're going to sweep from 0.1 volts to 2.5. 101 points is fine. Okay, we're measuring everything. Okay, done. So now if I go here, see I'm on diode. Oops. So when I click here, I should get the diode. All right, and I do, because I have a diode in there, and the long side is on 1. Now this plot is the resistor, so if I want to plot the diode, right, this is what I do. Okay, now this Nope. All right, now I'm going to do it again, and I should get a diode plot. This isn't, that's the old plot. All right, so I can see it's up there on the screen. All right, now yeah, I clicked that to minimize it. So it went back to resistor, so I have to click on diode. Now when I click on plot, it should come up. All right. And we see this diode behavior. And if I'm going to do it again, and we should see that diode blink. You know, this is kind of happening again. All right. It seems to be waiting for the 41. It's not talking to the machine properly. When it was clearly connected there a second ago. We can double check. We can start the NI Max program. All right. Devices and interfaces, it'll come. And then we have here's our USB GPIO. Everything seems fine. I can self-test it. Can scan for instruments. Right, it all seems like it's there. Let me come back here. That's right. Let me just double check config. The address is 10. If it wasn't 10, it wouldn't work. Okay, that's okay. Just double check. Right. The source, everything. Sweep. So I did it again. This is rather annoying. That'll save the diode and the resistor. I'll use this. Okay. Turning the machine off. Turning it on again. I'm going to pause while it boots. Okay, so I've been kind of turning it off and on again, getting out of the software, coming in. Seems to be working. Right now, what I suggest is to kind of measure what you can and then save it for analysis later. So maybe don't worry about the fits just yet. So what I did is MS Excel is on there. Oh, wait, actually it might already be there. Oops. Options, workspace. Okay, there's MSXL. So, oh, that went away. Let me try one more time. Workspace. I'm going to turn it off, turn it on, press OK. Okay. So, what I would do is just save it, because I'm having trouble with the software, right? So that was the red LED, right? Now that it's working, I put in the yellow one. I'm going to press single. Hopefully it works. I can hear it clicking. And I don't know, I'm going to try it again because I didn't see it blink. Now it's like working perfectly. Okay. So you can see that the IV curve is different. So then I would save as, you know, LED yellow. And I'm just doing this quickly. All right, now I'll put in the green. You should see it blink. Okay, might not have really fully turned on. So what one can do is go back here and say go up to 3 volts. All right, and run it. Oop, I didn't press. Forgot to press done. Okay. There we go. All right. Now we see that curve, right? File save as. Green. Okay. Now you can do that for the resistor and the regular diode. All right. Now what we can do is several things. All right. I'm sorry for the quality of the video, but I'm just going to plot this. All right. And you can see here that it's clipping. That's the compliance. So that's not really a valid measurement. So that's really at 2.26. So in fact, yeah, you can see that those are all clipping. So I'm going to delete it. Insert. Okay, so here's the thing. This is an exponential part. This is a resistive part. And so we can extract its series resistance in here. Let's say, you know, take a few data points from the highest. All right, so I'll take those, insert chart. All right, and now all I have to do is add a trend line. It's linear. I'm not going to set the intercept. Display equation, display R squared. And you can see the slope, which is 1 over the resistance, and R squared is pretty good. Great. But the diode has something It has the ideality factor, and it has the reverse saturation current, which you need from the exponential range, right? But we actually do the logarithm of the current. Oop. I'll show you in a second. And of course it's negative till it's really fully on. So we don't plot there, right? So what I'm going to do is just plot this and plot that. I just have to pause for a second. Okay, I made a plot of the natural log, right? And if it was purely exponential, it'd be a straight line. But it rolls off here, that's due to the resistance. And this is where it's not purely exponential yet. So you really want to find what looks linear. So I said, oh, about 1.2 to about 1.5. All right. So then I plotted that out just between there and there. And so I extract it. And so this, the intercept is the reverse saturation current. You just take the exponential, right, e to the minus whatever that is, 44, should give you that. And then the slope will give you the ideality factor if you know the temperature. I have notes on that, and I'm gonna just leave it there. This video is already long enough. But you can do that for each diode, and each diode, right, it'll have a different linear regime. Some diodes even have two distinct, right? Each diode, where did I put the resistance, right? Here, we'll just, each diode has a different resistive region. So you're gonna have to figure out where to do it for each one of those diodes. And the resistor, right, is just very simple because it should all be linear. So, sorry I said this last, right, but save the data to Excel and then analyze it. And again, some things I don't quite know why it was not doing what it was supposed to be doing. Sometimes if you go to edit and you change something and you forget to click, I change it and I forget to click done, right? Like I can't even select it. So I have to hit done. Now I'm just gonna, for laughs, go back to resistor and I can hear the machine clicking away, so it's working. So I'm just gonna log out. Now, of course, that Excel file, you can email it to yourself or you can even upload it and analyze it in Python. One of my favorite things. Anyway, have a good day.